That's going, recording. Cool. So the idea is that we talked about each earlier today, and that was fun for the entire family. Um, and the idea here is that we're going to look at some other enumerables. We're going to first recreate. We're going to start recreating the functionality of other enumerables. And we're going to introduce some new things, right? And so, like I said, earlier this week, we talked about each, and we used each to iterate over a collection, and we did a bunch of things with it. We transformed some collections. We grabbed like a small subset of a bigger collection, created some new things. And so iteration is something that we use constantly as programmers. And the great thing about Ruby is that it has some tools that are built into Ruby that help us kind of do like the most common tasks that someone would want to do with iteration, right? And we categorize these tools as enumerables as we enumerate. We essentially say we enumerate over things. I think that's another synonym for iteration. And these enumerable methods, what they do is that they are essentially like, you can think of it as like each plus, right? They essentially do what each does, but a little more. And so to kind of understand how these kind of work, we are going to kind of go ahead and like look at how things work with .each and then do it otherwise. So let's kind of talk about .each first, right? And we saw earlier. And if I can spell, there we go. This is kind of the general syntax for an each method, right? We have this collection, we have the each method, which we're going to use to iterate over it. We have the thing in the pipes, which is known as the block variable. Well, in the middle, like, you know, for line 2, I just have code in there because it's like whatever you want to do in there, and we have the end block. Because we have a do, we have an end, right? Whenever we have a do, we have an end. Like those two, they just go together. And as a habit, whenever I type in a do, I'll immediately type the end, because otherwise I will do something else and I'll forget to type the end, and then my code will work and I'll have to start digging and figuring out why. So good habit. And so like this is the general syntax. And the idea, the kind of like some big picture stuff about .each is that things we want to remember is that each will return the original collection, right? And the idea is that we use each. The best use case for each is when we're iterating over collection and there is not another enumerable that does the thing already, right? Each is like, hey, this is kind of like our kind of prototype that we use, and there isn't something else that's going to do the job better for us. Questions so far about .each? So far, we kind of recap what we talked about previously, and it's been fun. Cool. So one of the things that we talked about with each is that each always returns the original array. And when we use each, we need to use a placeholder, this aggregator collector, to preserve the return value we're looking for, right? And so I'm going to copy and paste this so you don't have to watch me type like that. And we have this bit of code here. Also, is this big enough for everyone? I just want to make sure. You good? Cool. We have this array of numbers, 1, 2, 3, 4, 5. We set this aggregator called doubles, and what we're going to do is that we're going to go through each item in this numbers array, and we're going to double it, as in multiply it by 2, and then take that result, and we're going to put it into this doubles aggregator. And then afterwards, we want to print it out. We would do a puts doubles, and this would print it out to the screen. Let me go ahead and run it. Nope. And he's here, 2, 4, 6, 8, 10. Right. That's the right math. And so, knowing what we know about return values, let's say I did this, and then I have this method. Take a minute And I'll call on one of you for an answer. But what do we think we're going to see when we put this up to, when we run this and it puts double out to the screen? I will pick the one of you that looks the most thoughtful today. I don't know how to judge if someone looks thoughtful. Anyone wearing a hat? Catherine, because you're also drinking. I like to pick on people who are drinking because it's just fun for me.
Yeah. Did you mean to say puts doubles at the last line? 11 there? Double.
Mm-hmm. So what do you think's gonna? What I'm gonna do is I'm gonna hit up and I'm gonna hit enter. What's gonna appear on my screen when I hit enter?
I think it's going to maybe just put the numbers array. I'm not sure.
So I mean, like numbers array mean like 1, 2, 3, 4, 5.
Yeah.
All right, I'm gonna hit enter. At this moment where I couldn't find my enter key.
Well, okay. So if it's going to do the last block.
You can't go well after I've hit, I've hit the button.
If it does the
right
last
the first
block,
time.
then there's nothing. I was right the first time.
Yes.
Is that right?
Yes.
Oh,
so
great.
We see,
good.
Okay,
actually, stick with my gut.
That a little
Be
bigger.
confident.
Yeah, stick with your gut.
Okay.
Let me make that a little bigger. Cool. It's 1, 2, 3, 4, 5. And the reason why this happens is that we need to remember two things here. The first thing we got to remember is that each will return the original collection. That's step one. Step two is that in a method, the last line of code is what gets returned. So, like using that two steps of logic, the last line of code, like, yeah, this is technically 3 lines, but it's because with the do in the end, we treat that as one chunk of code. And so that is what gets returned. And we just said that when in each, it returns the original collection. So that original collection is 1, 2, 3, 4, 5. So like, well, what do I got to do? I have to, if I want to return the 2, 4, whatever, I have to do this. And when I run it again, I should get that 2, 4, 6, 8, 10. Because what this method returns is the last line run in the method, which is going to be that aggregator, that collector. Like this is a pattern you will see pretty often when you're using each. Questions about this part? Catherine?
Yeah. Would you mind explaining it again? So how come it doesn't put just the empty doubles array? Isn't that technically the last?
Because we put the double numbers into the doubles array here.
Okay.
So let's kind of walk through this, right?
Yeah.
We run this file, and Ruby says, okay, we got a method, cool, it does this stuff. We'll remember we have a method called double, excellent. Don't do anything now because all we have is the definition of a method. It gets down here and says puts double, like, oh, well, I know what double is, so let's run the double method and get that return value. So we go up to double. I'm like, okay, we're now in the double method. Let's set this array of 1, 2, 3, 4, 5 equal to this variable numbers. Got it. We're going to create a variable called doubles, and that's going to be an empty array. Got it. Oh, we got numbers.each do. Okay, so we are now going to iterate over this numbers, right? So we're going to go 5 times. The first time through, number is equal to 1. We're going to multiply that by 2, which is 2. Put that into doubles. So now doubles is just an array carrying 2. And then we do that 4 more times for each number. And so now after the 5th run through, because there are 5 items in each, doubles is now going to be this array containing 2, 4, 6, 8, 10. And now we are returning that. And now that return value of that array is now going to be put out to the screen.
Perfect. Thanks.
Cool. Yep. Joseph?
So this is kind of a silly question, but this problem is reminding me of something that I got held up on the pre-work forever, and the difference between doubles and multiplication, where
What do you mean by the difference between doubles and
so
multiplication?
you actually answered a question about this in a chat a while back. There was a question where it asked us to print doubles, but it's actually just the multiplication of oh, you know what? I'm wrong. Never mind. Sorry. I realized my mistake.
Okay. Sure. Isabel?
I'm just, I think, a bit confused on how when we write doubles within this each method, for each loop, how come it is now overwriting putting out that original array? Like how you said at the end of like we'll always put back that original array. How come now it suddenly is just not?
What do you mean suddenly it's not?
So like suddenly it's like not, it's giving us now the doubles array instead of that original one, the 1, 2, 3, 4, 5.
Yeah. So the thing is that we are running each on the numbers array. Now each will not modify the numbers array. It will not modify the collection it's called on. However, in the block of code within the do end loop, within the do end inside the each, we do whatever we want in it. We have access to all the variables at the same level of scope, and so that's how we have access to doubles. When you talk about scope, did we talk about closures at all? No. So essentially what happens is that when we use each, right, we know that like it has this kind of this scope within the block of each, but it also has this thing that's called a closure. What it does is it brings in all the stuff outside of it at the same level. So that's how I have access to doubles as well as number. Ben?
I kind of came up with like a really weird analogy. Let me see if this is actually correct. So you know those like big tubes in those game shows where you have like money swirling around and you have to like catch it?
Sure.
So like if you
Okay.
imagine that you had nubs for hands and you couldn't actually like grab onto the money with your hands. So I think that like when you run that each thing, yeah, right. But like you're not going to get very much for that. And so you can imagine like the money that's spinning around is like the each running and kind of modifying everything. And then once you have like, if, you know, once you get out of it, you don't have any money because like, you know, you didn't grab into it. But if you had like a trash can or a trash bag attached to your hand and you were like kind of scooped in the money and then you walked out of the thing, you now have the data inside of the little trash bag that you took with you. And I think the trash bag is kind of like the doubles array.
I mean,
so kind of like
yeah, that does work, but the idea here is that what Enumerables do is that they give you this feature called the closure, which is essentially like, I like to think of it as like an omelet because I love omelets, and they kind of fold over all the other local variable scope that happens inside this method. Cool. All right, so that works. James?
Let's see. Yeah, just real quick too. I think to add to what Isabella was asking, when you run, you have your numbers array, you have your empty doubles array, you have numbers.each. Numbers.each still returns the original numbers array, but it also shoveled number times 2 into doubles. So when you add doubles outside of that, that's what the definition double is actually returning when you puts double down below. As soon as you take away the doubles, numbers.each still returns the original numbers. Doesn't matter what you did inside, except it stored that information in the doubles.
Yeah, because what returns from a method is the last line. Like if I were to put, for example, if I were to be weird, always weird, but you get the idea. Pizza there. What's going to get printed out to the screen? Pizza, because it's the last line, right? It doesn't matter what we do. What is the last line is what matters, what counts. Cool. All right. Let us move on. let's kind of talk about the first big enumeral we're going to use. We saw this idea of like, we're going to do this where we want to, just do this kind of pattern here. And I think that this pattern is something you're going to see as you get used to using each a lot, is that you have a collection, you set up a collector, you iterate over thing, you put things into that collector, and you return that collector as the last step in your method. But it's fine. It's fine when we're starting. But the idea is that like it's a little inefficient, right? It's inefficient in the fact that doubles here, we're using the local variable to kind of hold something. And local variables, they take up space, they take up resources. And is there a better way to do that? And yeah, we have a method called map. You may also refer to it as collect. Both do the method names are exactly the same thing. And the idea here is that Ruby was built to appeal programs from other languages. And in other languages, some people call it map, some people call it collect. I use map because it's shorter to type. But mentally, I think that collect is a much more apt descriptor of what it does, right? And if we were to do this, if we wanted to make this, we want to replicate this functionality above using map, it would look like this. Double, and I'm just gonna numbers, and we're gonna do and then we would just do that double like so. What this is doing is that, and we don't even need this. We could just do this. What map does is that it's going to iterate through each single item in this collection, and the return value of the block, like whatever the last thing in the block is going to take the place of the thing. So map will always create a collection that is the same size of the original collection. And for each place, it is going to be whatever the return value of this block is. Ben?
Yeah, I more had a question about kind of a runtime thing. When you have two methods that have the same name, is it when at runtime, is that going to give you an error, or will it just kind of assume?
Let's put that in the parking lot. Like that's
Okay.
not really what we're talking about right now.
Sorry.
Cool. So I'm going to go ahead and pop that out. And did I put a puts double at the end? Yep, I did. Save it. And we see that it prints out the numbers. And if we look between the two, we can see that, let me see. Okay. Oops. Kind of compress this a little bit so you can see both at the same time. Cleaner, we're using fewer local variables. Overall. Cool. Questions about map so far? All right, so we're going to give you an opportunity to practice. Dun, dun, dun. Oops. I'm going to drop some code in your Slack channel. Oops. Cool. I'm going to put you in your breakout groups. You're going to take 5 minutes and essentially recreate what I have here for you in using .map. Just give me a second to move to 18. Cool. Off you go. Hello. I want to put you in breakout rooms so you could see things happening rather than hanging out here with me. Back up and let's, yep, that's going. And let's kind of go over what we did in the breakout rooms. Like we have the Kennedy Brothers method. Looking at this, we're using each in order to, it looks like we want it so that we get back an array where all the names are just uppercase, like all the letters all in caps. Cool. And we want to retrofit this. We want to use map, a much more efficient method than .each. Well, the first thing we can do here is that we can remove that line and that line because we are no longer going to be using this collector variable that sits outside. And we are going to go over here. I'm going to go over here. I'm going to change this to map. And I am going to delete this bit here. Nope, that is the wrong button. And then we have that. Let me get rid of the extra white space. And I'm going to do puts Kennedy Brothers. Save the file. And I'm going to run it. And if I've done this correctly, we will see that we will have Robert, Ted, Joseph, John, all in caps. And we do. Right, and kind of repeat what's going on here is that we have this brothers array, Robert, Ted, Joseph, John, all capitalized properly with the first letter capitalized. And what map does here is that it's going to iterate through each one, and it's going to create us a new array. And for each position in this original brothers array, it is going to put inside of it the name of the brothers currently on. And so like the first time we go through, it's going to have in its internal memory this little empty array. First time through, it's going to take Robert. I'm like, okay, Robert, I'm going to upcase, put you all in the caps. I'm going to put you into my new collector array. And so now we have this array with just Robert all in caps. It grows through again. Now we're at Ted. Ted is going to get capital upcased and then placed into that array, and then repeat on and on with Joseph and John. And if there were 5 more Kennedy brothers, we would go through them and capitalize all their names. And then what map does is that, again, the difference between map and each is that map returns us the entire new collection as opposed to the original collection. And that's how we don't have to explicitly return that new array as we did with .each. Kind of want to open it up to questions about what we've done here together, if there are any. Let's go Jordan and then James.
Yeah, I was just wondering, I'm not sure if this is something to put in the chat or whatever later, but
Sure.
Each bang versus map, is that a question we're talking about right now? Like each exclamation point? Is that similar to map?
Yes and no. I think that when I want to use dot each bang, right, that what that does is that each bang will modify the original collection, and things that like we talked about yesterday, we don't want to modify the original collection. That whole analogy with the witches and the cauldron, right? Dot map also does not modify the original collection. If I were to do a puts brother, if you do put you run this, you do puts brothers, it will still be just the capital R, T, J, and J, right? We
Got
want to
it.
try
So
to avoid.
the map allows you to keep the original it gives you a new one as well, but doesn't force the original one to. Okay, cool. Thank you.
Yeah. So I think a good way to think of it is that what dot map does, as opposed to dot each, is that dot map is a shortcut to having you to set up that collector aggregator array, like we did with dot each, right? That's kind of like the main difference between the two. Cool. Good question. Great question. I saw another hand that has disappeared. Was the question answered?
Yeah, it
Speak
was
now, forever
the
hold
same
your peace.
question.
Cool.
I was wondering if map
Cool.
with the bang or exclamation point, it's destructive, right? So it would
Yeah.
completely rewrite the. Okay,
Mhm.
awesome. Thank
Yeah, and again, like I kind of want to just kind of reiterate, like we want in general, we want to avoid a situation where we're mutating the original collection, because this can cause a lot of headaches later on. And I realize that I do say in general a lot, because the idea is that if we never had to do it, they wouldn't let us, right? But there's always going to be that one situation, that really offbeat, weird thing you got to do to get this done, and that's when that kind of takes place. But like when, like I do qualify a lot what I say, because it's like, again, if they never want us to do it, they would not have made this ability for us to do it. So if that tool is there for your use, just don't use it, and that'll come with experience. Yeah, Aiden?
What if we wanted like the new array returned instead of a name on each line?
So that's a good question. Like they're asking what if we want the new array instead of what's on each line. So the thing is that this is the array, the new array is getting returned, is that when we put an array, it looks like this. Now, if I wanted to, what we can do is that I can throw a dot inspect at the end of this. And what this inspect method does is that it is going to kind of print it to the screen, or it's going to reformat in a way that is very clear that it is an array. So I want to do this again, and we can see here, it is in the brackets with the quotes, and that's what inspect does. And so I also want to kind of, let me do this here, where I'm going to take that out. And I'm going to, we talked about this briefly yesterday. If I change this to P, it will do the same thing. P is kind of a shorthand for puts plus inspect. And I also want to note that I saw in a number of your independent challenges yesterday, a lot of people using P. In independent challenges, we generally do not want to print out to the screen. And so another interesting wrinkle about P is that it returns the thing as well. So that's why your code was passing. But in general, we do not want to output anything to the screen. We want to let our tests kind of drive and verify that things are working the way we want it to. But cool, that was a fantastic thing to bring up. And thank you for giving me the opportunity to do that. Cool, let's move on. So one of my favorite things about Ruby is that the methods so often sound like they do the thing they're supposed to do, right? So what we're going to do is we're going to talk about the next new rule on our list, find. Now, what do we think find does? Anyone would like to pop their hand up and take a stab? Ben.
What I think it does is it'll, iterate through a certain section of data and then match, the argument or delimiter to, and then kind of pick up, where each of them are stored and then return only the what you want it to find.
Yeah, cool. Yeah. So what find does is that it finds a thing. It literally just goes finds a thing. And so the next thing we're going to talk about is find. It's also known as detect. And I have issues with calling it detect, which we'll talk about in a little bit when we get to the next one. But we'll call it find. And what find does is that it will find the first thing in an item in a collection for us. So let's do this. I'm just going to, what we're going to talk about is we're going to implement this using .each here. If I can just navigate my computer for once. Here we go. And this is how we would do it with .each. And looking at this, we have named the method well here. Find me the first even. We set it up by having an array of numbers, 1, 2, 3, 4, 5, our good friend. We are now going to iterate through each of these numbers. And what we're doing here is that this is a little bit different format that you've seen in the past. This is what's something called a guard statement. And it's designed to kind of protect against the situation. It's going to run the code on the left when the right side return is evaluates the true. So the first time it's going to run through, num is going to equal 1. So it's say, hey, is 1 even? 1 is not even, so nothing happens. We run through it again. Num is now 2. Cool. We evaluate the right-hand side here. Is 2 even? The last time I checked, 2 was even. So unless they've changed that recently, this is going to, the right-hand side of this statement is going to evaluate 2. And so the left-hand portion of this is now going to run, return num. And when we do return num like this, it's going to halt that iteration and just give me back whatever I'm returning. So now this stops at 2. So if I were to run, oops. Let's find the first even. It grabs me the 2. Right? And I think it's very, very important to remember that find will grab you the first item for which this returns true. So now let's do the thing that we did earlier, right? How can we convert, how can we use find instead? And so when we use find, it's going to look like this. Numbers.find do num and num.even end. And so what we're doing here is that what find does is that for the first item that's iterating through where this bit of code, this block here returns true, it will take that and return that. So what's going to happen is like, hey, we're going to run through 1. Is 1 even? Is 1.even true? It is false. Nothing happens. It goes back around. We're now on 2. Is 2.even true? Yes, it is. 2 gets returned. We're done. Mike?
I suppose my question will be answered when you run this, but I was wondering what end of the array does find start searching for? Like, is it the 0 or the -1 indice?
It starts at 0.
Okay.
Yeah, that's a great question. Yeah, it'll generally these what I call the finder. Well, let me rephrase. In enumerables, in general, it will start at the beginning. What we consider the beginning means 0 index. There are probably ways to make it start from the end, but I don't remember them off the top of my head. And if I need to do that, I would just reverse the array and then do it that way, because it's just like that's just the easiest thing. I know that'll work, and I don't have to go searching for whatever code it will take. Like it's just simpler to do it that way.
Cheers.
Yeah. Cool. Other questions so far? Cool. All right. We feel good about find? Find, yeah. We're just finding a thing. It's like looking for your keys. Something that I do on a daily basis. So what we're going to do is I'm going to put in your chat an array. And we're going to take 5 minutes. And I'd like you to find the first sister. These are the Kennedy sisters. The first sisters where their name is longer than 4 letters in length. First sister with the name longer than 4 letters in length. That should be Kathleen. And I'm going to put you into new breakout groups. Just bear with me. We're going to recreate them. And we're going to have a couple more people in here.
Sorry, just you want it longer than how many characters?
4.
Okay, cool.
Cool. This should be good. And take 5 minutes. Chelsea, did you want to be assigned to a group? Let's resume recording. And let's talk about it. So we want to grab, to select out of this bunch, the first sister whose name is greater than 4 characters in length. Sisters dot find do sister. Oh, we should retheme this to be Hamilton team. That'd be great. Sister dot length. And we said greater than 4 letters in character length, so that should be it. Cool. And I'm going to do puts find sisters. Kathleen, as predicted. Questions about find? Fairly straightforward. Catherine?
Can you give us an example? I mean, I guess this is an example of when you would use it, but surely when you're using, like if you wanted to find the sisters' names who are longer than 4 characters, there's more than just Kathleen. So when would it actually be a good, if you knew there was just one, or I guess
you can see here there's 3 that are longer than 4, right?
Right.
This just grabs the first.
So I don't know, it doesn't seem very practical. Why would you just want the first one? I'm hoping you can give me another example of when I would want to use find in real life.
I think when you know that there is only going to be one, since find is going to like find it and then pop out, whereas find all, which you all we'll keep going. I think when you know there's only one, that would be my go-to for that.
Okay.
So I think a good use case here is that we're forgetting that the other name for this. Catherine, do you remember what the other name for find is?
No.
It's fine. Detect.
Okay.
Right? And the idea here is that if it gives us back something, we know there's at least one. Right? So the fact that it returns us the first one is kind of like this bonus. Right? We're trying to see like, hey, is there one of these that exists that's in here, and just grabbing the first one. I can tell you that I don't remember offhand right now, but there have been situations where I've used find. Like that's been like I've had to find. It's generally that you don't necessarily care at the first one. You just want one of them, and you don't care which one it is where I would use like a find. That just happens to be the first is immaterial to me.
Okay, thank you.
Sam?
Whenever I use find, I keep on getting an enumerator returned. And I did the exact same thing as you. I guess I didn't put it in a method, find sister. I just had like a global sister.find do sister.
Yeah. Let's put that in the thread. We'll talk about that afterwards.
Okay.
Liam?
Is there like a map equivalent for find?
Oh, a what?
Like a dot map equivalent for find where it'll like find it and then put it in its own separate like array? Like if you were gonna do find all to like find multiple of them?
Yeah. Well, the thing is that this returns the thing itself because we're not going to put it in an array because we just want the one thing.
Okay, I guess I was more just
Right.
curious.
Yeah, there is not one word. Well, if you wanted to put that in an array, I guess I would. Yeah, I would do something like this.
Actually, reading what James just said, I guess you could just do dot map and then all greater than 4, and it would
Yeah.
do the same thing as find all, and then putting
Yeah.
it in.
Right,
Okay.
but then at that point, you use find all, which we're gonna like. I could do that. You could do something like this. If we do, I guess we gotta do a. Whoops. You get the idea.
Yeah, I think I got it.
Right. The idea is that like if you're just dealing with one thing, like there's no need to put in an array. We don't need to do that. Cool, Ben.
Yeah, I was just kind of had a question about when you put a puts in front of the sister dot length, it'll actually return a Boolean value for all of them. And so sister would find it'll go through the entire. You said it'll go through the entire thing, right, and not just stop at the first one.
No, it's find stops at the first one.
But when you put a puts in front of the on line 2, it'll return a Boolean value for the entire array.
What's the Boolean value?
So like,
no, what is
it'll just like
false.
Yeah, it'll return true if it's greater than 4, and then false if it's not.
Yeah, I'd have to poke into that. Like the idea is that you wouldn't do that. You would not put
Okay.
Put a put statement inside the find block. Sydney.
So I just wanted to add a comment just on the question before, and I forget. I'm sorry who asked. But like one thing that I would recommend is like as we learn these enumerables, like learning the return values at the same time. Because last time I went through this, I didn't do that. So I knew all these methods, but I didn't understand the return values. So I would say learn them together, like and then that'll answer a lot of those questions.
Great point. Cool. Let's take another break. Let's be back at 11:13. 11:13. Recording and let's go. All right. So we talked about finding one thing. Let's now find them all. Find all the things. And the method we use that is find all, otherwise known as select. And I kind of go back to what I was saying before, like I always use find all because in my mind that's very easy to remember what they do. Find grabs me one, find all, like the name says, finds me all of them. Whereas with select and detect, it's like, what does each do again? Like it's not intuitive to me, like what the difference between select and detect is, especially since they rhyme. I feel that makes it worse to remember what they do. So I usually just stick to find all because it's very clear, it's very expressive about what it's supposed to do. And so with find, what we've done is we've gotten one matching thing out of an array. But what if we want to grab more? What if we want all the things? And to do that, let's say we knew not about the wonders that is find all, we would do something like this. We want all the odds. We have the numbers, our good friend. We have a result, and we're shoveling into the result if the number is odd, right? And this is fine. But the thing is that we are stuck with this result container that we don't kind of want to use, right? And the thing is that when we have this kind of pattern where we have this, the collector aggregator that we're shoveling something in, odds are that we need you to find a better enumerable, right? Like we showed you how to use each, and I think using each is a very good starting point, but we want to get used to not using each. You want to get used to moving on to the what I call the purpose-built enumerators. They're going to be more efficient and faster doing the job. And so we're going to use find all. And if I wanted to retrofit this to do that, we would do numbers.find all, do num, and what it's going to do is it's going to create a collection for each item so long as the block returns true. So for every single item, when we're numbering through where this part here returns true, it is going to add that to the collection. And when we do a puts all the odds, and we get the 1, the 3, and the 5. Questions about find all? Explaining these gets quicker and quicker as we go on, because there is certainly a repeated pattern to them. I'm going to take that silence as no real questions. One question I have for you is that in your breakout groups, is 5 minutes an appropriate, reasonable amount of time? Has that been okay? I see mostly nods. Cool. Just want to make sure. So we're going to do it again. I'm going to post a bit of code. No, what did I do? I don't know. I put an array of numbers in there. And what I'd like you to do is grab all the numbers that are divisible by 3. Divisible by 3. So theoretically 3, 6, and 9 in this bunch. Let me formulate some new breakout groups. I'm going to recreate them. Wrong button. Cool. And let's take 5 minutes to do this. And what I'm going to do, I'm going to copy this. I'm going to paste in the number. And I need to find all the things. Excellent. So we're going to take numbers dot find all do num. And so we need to grab all the numbers divisible by 3. And for this, we're going to use our fun friend, the modulo operator, where the modulo operator essentially does a division and gives you back the remainder. So what I'm going to do is num modulo 3 is 0. So when there is a no remainder, it is going to be divisible by 3. And this should do the thing. Oops. Cool. Excellent. So what we've done here is we've walked through 3 of the most common enumerables as a class. These are probably, is that a misnomer? Common? Yeah, find and find all, I would say, are pretty common to use. And what we're going to do is that we're going to give you some time to do some independent research. So what we're going to do is that we are going to put you back into new breakout groups. And I am going to put this list into your Slack channel. And what I'd like you to do is that in your group, kind of research what these do. And when we come back, we'll come back in about 15 minutes. And we'll discuss, we'll have each group kind of like talk about them. Let's make some new groups. Let's make some new groups. And off you go. Sure. some of these, I'm going to go through these, and I'm going to ask one person from each group to kind of talk about one of them. Let's see here. Robert, tell us about Max.
So what Max is doing is it's finding the individual things that are the maximum of whatever value, and so it's similar to max by as well.
No, we're not talking about max by. We just talk about the one.
So yeah, so max is just finding the maximum of
cool
by value.
Yeah, excellent, fantastic. So like, I feel that we don't need to talk about min because that's the opposite. Eli, tell us about max by.
All right, so as far as I know, max by does like pretty much the same thing, and I couldn't really figure out what the difference was. Neither could my group.
Okay. Who's familiar with max by wants to kind of take a stab at it? Vanessa?
I mean, I wouldn't say I'm familiar, but I think that with max by you have one extra. It's a little bit more dynamic in the sense that you can actually provide arguments. So like if you put integer 2, then you're gonna get the first. So you want the longest words. So then you put 2 there, you're gonna get the 2 longest words. That is the only difference that I saw.
Yeah. So essentially the difference between max is it'll give you like, it'll do like a comparison. Like if you have an array of numbers, it'll give you the largest number. And the thing is that we have some things that we can't normally, like, how do you compare apples and oranges, right? Like, well, you can, but you can't compare two dissimilar objects. You can't compare. But however, max by, that by is very telling in the fact that the by allows us to determine like, hey, we want to get the biggest, the maximum in context of a certain criteria. So we can do a max by like the length of the string or any other thing we can come up with. But excellent answer. Sort by, let's hear from Mike.
Yeah, so much like its name, it sorts your collection by a certain condition. So everything, depending on elements, if the element meets the condition, then it will sort those elements into another subarray or subcategory. Not subarray.
Right.
Yeah.
An array. Excellent. Cool. So the second half of this are more interesting ones. Let's hear from Liam. Liam, what about all? What does all question mark do? You're muted.
Whoops, forgot about that part. It'll iterate over the array, and it will check to see that every element in the array meets the criteria that you specify, and if that is the case, it will return a value of true. Or so long as everything doesn't return false or nil when it's checking that criteria, it'll return true.
Yeah, cool, excellent. Joe, you have your hand up?
Yeah, I have a question about sort by. On the Ruby docs where it says like the current implementation of sort by generates an array of tuples containing original collection. Tuples. Yeah. So that whole sentence just no idea what it's saying.
Yeah, it's just a little more description of what's happening at the lower level. Essentially what it's doing is that it's generating these pairs that it kind of compares to. Like if you are interested in how that works, you can go look at the GitHub source code for that, but like for our purposes, not necessary.
Okay, thanks.
Cool. Let's move on to any. And Karen, we can talk about what any does.
Sorry, I'm slow.
It's all right.
Okay. Passes each element of the collection to the given block. The method returns true if the block ever returns a value other than false or nil. I can't explain this in my own words, so I'm just reading it off of Ruby docs. If the block is not given, Ruby adds an implicit block of block variable object that will cause any to return true if at least one of the collection members is not false or nil.
Yeah, so essentially what's happening is looking like in the block we have a conditional, much like we have with like this find all. And the idea is that if any of them return true, it will return true. So these enumerable methods that have a question mark, they don't return a collection, they return true or false. And we use any to figure out if anything in here meets this criteria. Ben?
Something that kind of helps me rationalize any and all is they kind of behave similarly, like the logic behind them kind of behaves similarly to like the and or conditional operators. So like for any kind of behaves like the or if it's any one instance is like a false condition, it'll return, you know, X and or whatever it is. And then for all, it's like, because for the, you know, for the and logical thing, it's both of them have to be true for it to be true. And so it's either, you know, all or nothing. If one of them is false, it returns false. I just maybe it made it easier for me to rationalize it.
Let's move on to the next one. Megan, can you talk about none?
Yeah. So it's going to iterate through and look to see if there are any instances of what you pass into it. And if there are, it's going to return false. Sorry, is that right?
Fantastic. Yep.
Yeah.
And we got one left. So James, can you talk about one?
Yeah, so one is similar to any where you have a condition that you're trying to meet, but if there's more than one that returns true, it
Is James breaking up for anyone else? Okay. I think we've lost James. I thought it was just me, but like he's still, and everyone's moving, so I'm gonna I'll take a screenshot of that. Aiden, can you oh wait, oh nope.
Oh.
This is awkward now. Okay, well, let's just hear from Aiden.
I can do it. All right. One returns true if exactly one of the objects returns true for the code block.
Fantastic. Awesome. Cool. So those are a number of like the big enumerables that you're going to be using. To kind of recap, we want you to kind of start moving away from .each. .each is great. It does have its uses, but like if there is another purpose-built enumerable, we want to use that instead. Some other notes for the at some point today, there are some check for understanding questions in the lesson plan. Feel free to go and answer them. There's just 3. Go over there and answer them probably like sometime this evening as you had time to have things sit in. This afternoon, if we look at the calendar, we have GitHub class at 1, and we have project check-ins from 2 to 4. Project check-ins are we'll be meeting you on a group basis, talk about your projects. This is a space for you to come up with to ask questions about your project. We're going to check and see what your progress is on the project is. It is very, it's kind of important that you do have questions ready to ask during that time. Any other questions related to enumerables before we go for break for lunch? Cool. You're all set. Have a good lunch. We'll see you at 1.